This diagram is called a finite state machine. Sometimes it's necessary to plan out the artificial intelligence states of a robot if it's trying to solve a task or respond to different conditions by using a diagram before you begin programming it. And finite state machines are one way of representing it. They're kind of like a flowchart, except they're actually a little bit easier to understand. Now, you can think of it as if we had a game where you have a piece, I'm going to use my mouse pointer to represent the piece, that's sitting on any one of these circles, and that's its current state. And we can look for certain conditions that will cause it to transition and move to a different state, or possibly move back to the first state. The starting position, in other words, the starting state is represented by the V, and then any ending states are represented by a double circle. So let's look at this specific diagram. Let's pretend that this diagram represents the behavior of some small rodent like a prairie dog, like one of those little rodents that, every once in a while pops its head out of its hole, looks for danger. If it sees danger, it might go back to its hole, right? So we have a prairie dog, and let's say that he begins by hiding. He's inside of his hole, and then if he hears something, if he hears a noise, it'll cause him to transition into this peaking state. So he'll do something, like maybe pop his head out of the hole and look for danger. Now, if he doesn't see danger, if it's all clear, he might go back to hiding in his hole, doing whatever it is that a prairie dog does inside of its hole. If it hears noise again, it could also transition back to the peaking state. It could go back and forth like this. Now, let's say that this time when it peaks, it sees a predator, like a large wolf or something that eats prairie dogs. If it sees danger, then all of a sudden it starts running, and maybe it starts running through the tunnels where the prairie dog hole is into the little prairie dog hole network. But the point is, you'll notice that we can only detect the danger condition if we're inside of the peaking state. There is no transition from the hiding state to the running state directly, and therefore we do have to respond to those specific conditions. Now, the rules for a finite state machine are that you have to have one starting condition. You can have more than one ending condition, just knowing that there's no way to get out of that running state. And there are arrows. Those arrows only go in one direction from one of the states to the next state. And those arrows are the transitions, and we label the transitions with the specific condition that causes that transition to happen. What this means is that after we create this state diagram, it's actually very easy to translate the state diagram into code, which we will show you in the next video.